In this lesson, we're going to be learning about and working with 3D camera tracking. Okay, so one of the first things I want you to notice is that this footage says undistorted in the title. And that's because I've included two different sets of frames of this shot for you. So I want you to go ahead and read in and get into that Girl in the Field folder in your materials folder. And you'll see there's a regular one and an undistorted one. So let's go ahead and read in the regular one. The undistorted one I brought in because normally you're going to do your camera track relatively early on in your production process, but because this was an introduction to Nuke for you After Effects users, I didn't want this to be kind of just jumping in totally head first with that. There's some other more simple things we could start with before we're, working on this camera stuff. So the problem is that whenever you do your camera track, if you don't know some stuff about your lens, it can actually create an undistortion node for you. So I just went ahead and created that, rendered it out, and incorporated that for you, because otherwise, if we actually hook up over here and look at this, the footage looks a little bit different. You can see that changed there. So the issue would be that if we did all of our rotoscoping to the footage, along this line here, with it being undistorted, then once we undistort the actual footage, which I'm going to show you how to do, then it's going to line up. Whereas if we would have, started with the footage that had not had anything done to it, our rotoscope wouldn't have matched up after we fixed the distortion. So we don't need this undistorted read node anymore. We just are going to stick with the regular one, and then we'll fix it with our camera tracker. So let's go ahead and add our camera tracker node. And we're going to plug it in right here. And then I'll just select it and hit the 1 key to view. And what we want to do is put in the right information here. So all of this, starts out, we're fine. These are the things that we need to tell it about, though. So, in After Effects, when you're using After Effects Camera Tracker, you're really just slapping it on. It's an effect and you go. There's not a lot for you to input about these, different things about the camera. Now, in our case, we don't have a lot of this information. So we're going to be going somewhat similarly to how you would be using this same technology in After Effects. So free camera is what the camera motion defaults to, but there's some other options as well. Now, rotation, we're not getting any kind of rotation here. We're just sort of doing the slow pan up. So then you might say, okay, well, that sounds like linear, but it also kind of sounds like planar. So what's the difference? Linear would mean if we were only moving in one axis. So if we were zooming, in on the Z axis, up, just going up or left and right. Planar means that you're just kind of on one plane. So maybe you're moving in the X and Y axis, which is what we're doing. We're kind of starting down here in the bottom and then just moving up. So this is definitely a planar motion. So we'll choose that. Now, lens distortion right now, we do have lens distortion because we are on just the regular clip here. So we're just going to choose unknown lens. And then we have our focal length options. So this would be if we knew exactly what lens was used and what the focal length of that lens was, and it was fixed, then it would be known. If it was varying a little bit or the same, but we weren't sure exactly what it was, then you could choose the approximate. So if maybe you have a lens that's got a little bit of a range on it, then you might choose one of these if you weren't sure what it had been set to, and there was no zooming would be constant, but if there was some zooming, you would put varying. Unknown means we don't know the lens and it's zooming in and out. An unknown constant is what we have. So we don't know the lens, but we don't have any zooming. So we're going to choose unknown constant. Now, the film back preset, we don't know exactly what kind of camera this was shot on. I suspect maybe it was a DSLR or something, but I could be completely wrong about that. So I'm not going to make a guess. I'm just going to leave it at custom as it is. So let's go ahead and hit track and just see what happens. So what's going to happen is it's going to pop us back to the beginning and it's going to start tracking. Now it's going to take a little bit of time, and then there's 2 more steps to our process. So I'll pause while this continues to track. Okay, so our track is complete. Now, you'll notice that there's a lot of little track points up here in the sky, and you can think of those as not really real data. It's trying to look at those as depth, but really it's kind of all on the same plane and it's pretty far back. So I'm just going to draw a box around those points and delete them. So anything that you see that is, on a sky or something like that, where it's obviously not going to be real data, then you can delete those. So I am just kind of scrubbing through here and looking for any other tracking points that may be in the sky, because our error rate, if we come over here to auto tracks, not our error rate, our minimum length is 3. That means it's got to be on here for at least 3 frames before it's considered a track that would stick. It still may have a high error rate, but if it's on there for at least 3, then we're going to see it. But in our case, that's why I'm having to go to different frames and scrub around. It's not like I'm just deleting that point. The sky may have different points at different times, as well as any other part of the footage. So now we've got our track in place. Let's come back over to our camera tracker, and now we're ready to solve it. So we've deleted those bad points, and I'll go ahead and hit solve. Now this takes a little bit of time as well. Not too much compared to the actual tracking, but it does have a little bit to do. And you can see that now we have actual keyframe data. Now our error is at 1.45 right now. So that's a little bit high. A lot of times you're trying to shoot for this number to be a 1. So we can go into our auto tracks tab here, and I can take these sliders down a bit. So if I come in and just move them a little bit down like that, you'll see we get more rejected tracks, which are going to be these red ones that have higher error rate. If I come back in, I can update my solve, and then this number should go down by decreasing that threshold. You'll see it went down to 1.39. Now, in my case, I could keep just moving this down, but the more I do, the less data I have. Now, granted, it might not be good data, but if you take it down to a point where you have like 0 errors, then you may, not even have anything to work with anymore. And in our case, because their feet aren't going to be visible, I hate to say this, but the track doesn't have to be absolutely perfect, because we're not going to see their feet kind of sliding around. They're going to be behind this little bit of the bush here. So I'm okay with having a solve that's not quite perfect in this case. Now, if I would have had more information about the footage, I definitely could have gotten a better one. Before we go ahead and create our camera based on this data, go back to your Auto Tracks tab, and we want to go ahead and delete our rejected tracks, which means it's going to delete the red ones. And this is just going to help us to have a better creation on our camera, so that there's not going to have so much of an issue in terms of a camera being created from bad data. So I also don't want to just create the camera. I could, but there's a few options here that can create multiple nodes, and we talked about in our last lesson what do we need? We need I'm just going to hover over this so you can kind of see. There's a list here of all the things that these different options create us. So the basic parts that we need were the scene, the camera, the scanline render, and a card or some type of geometry. Now that's going to come later because that's one of the inputs, but we need those basic 3 things. Now in our case, because our footage was not undistorted, we also need the undistort node. So we could use the scene plus. It's going to be a scene with a camera, a point cloud, a scanline render, and an undistort node. So let's go ahead and add a scene plus. So that's what I choose. I link my output, so in case anything does update or change, that will be linked to it. So when I hit create, it automatically creates me this nice little hierarchy. Now you can see if I move this away, this kind of got all jumbled up. So I'm just going to move this over here to the side. There we go. And my footage, you can see, has a lot to do with this lens distortion here. You can see that the source is going directly into that. Now, this lens distortion is undistorting my footage for me, so this is what I actually want to be plugging into up here. Now, when I view it, you can see that we get a little bit of an issue. So let me make sure that that's updating. Now, it may not look like a lot has changed here, but if I show you this number here, this is where you'll see the difference. So this is 1922 by 1081. And when I look up here, we just have 1920 by 1080. So it is a little bit of an undistort that's happening, and you can kind of see it just right here, barely on the edges. Now, you may get a slightly different result depending on what different sliders you dragged around and all of that kind of thing. So if your rotoscopes aren't matching up, you may need to adjust them a little bit. Luckily, that's a pretty easy and fast thing to do. So let's go ahead and move on to our next lesson, where we're going to start talking about more how we can use this 3D system to begin integrating different parts into our footage.